This tutorial is to help you in factoring polynomials, specifically those dealing with cubes. Sums and differences of cubes will be the pattern. The first thing is, can you recognize a cube? When you're looking at variables with exponents, if you can write them like this, then you know it's a perfect cube. So I have to think x to what power cubed will give me x to the 6th, and that would be x squared. X to the 3rd cubed gives me x to the 9th. If I had something like x to the 21st, I know that x to the 7th cubed gives me x to the 21st. So you notice that what all of these exponents have in common is that they are all divisible by 3. So if you have a variable, even something like m cubed n to the 15th, you could write that as m n to the 5th cubed, and this would be basically the cube root of this expression. You also need to remember what are perfect cubes for numbers. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed, 4 times 4 times 4, recognizing the 64, pattern. And so although forth. These patterns look very complicated, I'm going to break them down into 2 parts so that you can remember them better. First of all, notice that they are very similar in that they both have cubes in their patterns, of course, because it's the sums and differences of cubes. They both have a binomial times a trinomial. And notice that even within the binomial and the trinomial, x, y, y, x squared, xy, y squared, y squared. So even all of that's the same. The place they differ is in their signs. Here in the sum of cubes, sum because it's addition, you have a plus. And notice that the first sign is also a plus. So it's the same. Here you have subtraction because it's a difference, and notice that it's the same. It's subtraction. For our next sign, notice that it changes. It's the opposite of what you started. Here, same deal. It's the opposite. To our third and final sign, it's in both of them is plus, so it's always plus. And look what this spells, soap. So you can remember this pattern because of soap. So we have same, opposite, always plus for both. Now we have to figure out how can we remember how to go from our problem to all of this factorization with all of the x's and y's. If you rewrite your problem as we were doing previously, here the sum of cubes, you'll notice that whatever's here is here. So basically you're taking the cube root. So once you establish your binomial, then you can get your trinomial by doing this. The first one is squared. The second one is a multiplication. So x times y gives you your xy. And then, so that's multiplication. And then your last one is another square. So SMS. Square, multiply, square. In the bottom one, you'll first of all remember to set your signs using soap. Same, opposite, always plus. Then once you've taken your cube roots, it's a square, it's a multiplication, and then it's another square. So let's try a few. First of all, let's see if we can write these as cubes. This one can be the sum of cubes. The cube root of 64 is 4. So that one does follow our pattern. This one, 8, the cube root of 8 is 2. Cube root of x cubed is just x. Cube root of 27 is 3. X squared cubed is x to the 6th, and 1 cubed, square root of 1 is 1. Okay, this one, notice this one, first of all, I have to think about a greatest common factor. So this one has a greatest common factor of 3, so I'm going to factor that out first. And then I can write this as the difference of cubes. And I believe that writing this step is important. After you've done a whole lot of them, you might be able to skip it. But for right now, just learning the pattern is very important to go ahead and write it as either the sum or differences of cubes, because it gives you your first binomial, the first part of the pattern. So here is an example of using this pattern. So our first step is to recognize it. So there are no greatest common factors here, so I'm going to write it as the difference of cubes okay, and then my next step is I'm going to just form my binomial and my trinomial parentheses. So here's my binomial, here's my trinomial. The next step, I want to set my signs. I'm going to set my signs using SOAP. Same, opposite, always plus. So for this problem, it's a minus, so it's going to be the same, opposite, always plus. Okay, for the next part, I need to see what goes in these little blanks, okay, in between my signs. To fill in the binomial, I'm just using the cube root from my original problem. So it will be 2x and 5. To get my first blank in my trinomial, I square the 2x. Remember that it is 2x squared. So 2 squared is 4, x squared is x squared. To get my middle term, I multiply these two. So that gives me a 10x. And my last term, I square. So 5 squared is 25. Okay, here is some more practice. Well, this is the same problem, so let's change it. Sorry about that. So let's change it to m cubed minus 8. Okay, so my cube root, m cubed minus 2 cubed. So I'm going to set my parentheses, my binomial times my trinomial, because I've recognized what pattern it is. Set my signs, same, opposite, always plus. Using my cube roots, I get my binomial set. Then to get the first one, I square, so it will be m squared. To get the second one, I multiply, so that will be 2m. And to get the last one, I square. Okay, notice that once my signs are set using SOAP, I no longer am concerned about taking care of this. M times negative 2 would really be a negative 2m. But I've already taken care of my sign situation for the factorization. So once you've set your signs, don't concern yourself with what happens within the multiplication. Okay, let's try number 2. So I'm going to first of all write the cube roots, which would be 3 cubed gives me 27, m squared cubed gives me m to the 6th, and 4 cubed gives me 64. So I've written it in my, I've proven to myself that this is indeed the sum of cubes because I can write it in this form. Now I'm going to set my binomial and my trinomial parentheses. Then I'm going to set my signs. So it's same, this one's plus, so my first sign is plus. Opposite, always plus. Then in my binomial, it's my cube roots. So I'm just copying these. To get my first blank, I square. So 3m squared squared gives me 9m to the 4th. To get my middle term, it's 3m squared times 4. I'm multiplying, so that gives me 3 times 4 is 12m squared. And then to get my last one, I square again, and 4 squared is 16. So that's my complete factorization. Always remember to look for the greatest common factor. If you don't pull out your greatest common factor, oftentimes you won't see the pattern at all. For instance, with the first one, 2 is not a perfect cube. I recognize that x cubed and y cubed are perfect cubes. Neither is 16, and so it looks like it could be prime. However, when I find that I have a greatest common factor, I end up having the difference of cubes. The same thing happens here. I factor out the 5, I do have the sum of cubes. So you could pause the video here, work through these problems, and then come back and I'll have them worked out and you can check your work. Okay, how did you do?